How do you find the GCF of monomials? In this video, I will discuss how you define the GCF looking at two monomials. And last video, we discussed how to come up with the GCF for a constant. I just want to remind you that this is 8-1 out of your whole textbooks and for your notes. You can also find the GCF of monomials that include variables. To find the GCF of monomials, you can use prime factorization. So we're going to go ahead and use prime factorization to help us get the GCF of the monomials for this video. Here's our first example. Find the GCF of the pair of monomials, and here they are. These are two monomials, 15x to the third and 9x squared. So we're going to go ahead and reduce these down. So notice that on this slide, I have most of the work down for you. I'm just going to go to write a few extra things in. But what I want to remind you to do is pause the video, write down all the information, and then replay it when you're ready to follow along. So I'll assume that you paused and you wrote down all this information. So we're looking at two numbers. Let's first look at 15x to the third. Notice that we broken down the 15 first, and we got 3 and 5. Then we broke down the x to the third by writing them as factors. So that means to have 3 x's. For 9x squared, we looked at the 9 first, and we broke that down into prime factors. So we got 3 and 3. Then we took x squared, and then we wrote that twice, so we got x and x. And now you have to look to see what is in common. So they have a 3 in common, which is why we wrote a 3 here. They have 1x in common, which is here. And they have another x in common, which is here. So notice how I wrote all of those out to show what they have in common. So these are all common. And now I'm going to multiply together, and it will give me my GCF. So 3 times x is 3x squared. Therefore, the GCF of 15x to the third and 9x squared is 3x squared. Remember that once we multiplied all the commons together, this gave us our GCF. On the last example, I used prime factorization to come up with the GCF for a pair of monomials, and I did it the long way. So for this example here, we're going to find the GCF of 18g squared and 27g to the third, but I'm going to use a shortcut. And really the shortcut just is you thinking about it. So look at the numbers first, look at the coefficients. Look at 18 and look at 27. What number will go into 18 and 27 evenly? If you can't think about it, then you can list out your prime factors. For 18, you get 2 times 9, or to get it prime, we'll do 2 times 3 times 3. And then for 27, we can also break that down into factors, and that would be 3 times 3 times 3. But if you really thought about what number goes into 18 and 27 evenly, you would have thought of the number 9. 9 is the largest number that goes both into 18 and 27. And as you can see, we get that answer here. They have a 3 in common and another 3, and 3 times 3 equals 9. Now that we looked at the coefficient, let's look at the variables. So here we have g to the second and g to the third. So how many g's do they have in common? Well, it's the same idea as if you had rulers, right? Oh, excuse me, if you had rulers. So let's say you have 2 rulers. One person has 2 rulers, and then the next person has 3 rulers. So then how many rulers do they have in common? Well, they each have 2 rulers, or in this case, g squared. So, and if you can go ahead and list that out, right? If you did g times g up top and then g 3 times at the bottom, you'll notice that they have 2 g's in common. So our GCF for these two monomial is 9g squared. When you come into class tomorrow, we'll discuss how to use prime factorization and also how to use just general thinking to come up with your GCF for a pair of monomials.